in the previous lesson, okay, we take a look at angle at center equals to 2 angles at circumference. So I'm going to take reference from the diagram below. What you notice is that when the angle, okay, is extended from A and B to the center here, same 2 points A and B extended to the circumference. Okay, what we learn is that the angle at center is bigger and it is 2 times, okay, compared to angle at circumference. For today, we will actually explore another property, and I'm going to draw a circle on the screen first. Now, say for example, okay, just give me a moment. I have a circle, okay, and what happens is that I draw a line touching the circumference as such. Now, this line is known as a chord, C-H-O-R-D, okay. The chord actually separates the circle into 2 parts, okay, and where are these 2 parts? The first one over here, this portion, and the second one over here, this small portion here, right? Now, these 2 portions are known as segment. Okay, here, segment. Now, we can't call both of them segment. It'll be confusing. So, we notice that the yellow portion is bigger. So, we call it the major segment. The smaller one to be minor segment. Okay. Now, with that in mind, what I'm going to do is I am going to now introduce you the next property. Okay. Over here, I have a circle. Same thing like yesterday, I am going to select 2 points, A and B, on the circle. So you notice that if I have these 2 points, technically imagine this line, dotted line here, imaginary, right? It is actually separating your circle into 2 parts. Okay, one above here, right? This major segment, and then the other one below here, the minor segment. Okay, so what I'm going to do is, for today, I want to form 2 angles from A and B. Okay, so let me extend the line in the yellow region. Now, let me call this angle X. Okay, using the same 2 points A and B, I want to extend same area in the yellow region, and I call this angle Y. Okay, notice that both of the angle are in the same region, right? Now, I call these 2 angles, they are in the same segment. So, angles in same segment. Okay, so we can write a short form for the angles in same segment. We want to know what is the relationship between angle X and Y. So I'm going to show you an app very quickly here. Okay, just give me a moment. Let me sort this out. Okay, maximize. Now, what I'm seeing here, okay, we have 2 angles B and D, right? So from these 2 angles, what I can see is that over here, this angle here is 72 degrees, and this angle here also 72 degrees. Notice that the 2 angles, they are actually formed from the same 2 points, right? And they are in the same region, the same segment. Okay, so what this shows to us is that angles in the same segment, they are equal. Okay, they are equal. Alright, so I'm going to go back to this part here. When I have angles in the same segment, they have equal angle. So let me go to your textbook and we will take a look at a practice together. Okay, so over here, let's take a look at this example here. Okay, so in this figure, I have the following angles given, 25 degrees and 44 degrees. So you're supposed to find the first one, angle CDB. CDB, okay, being over there. So let me just screenshot this figure here. So in this example, okay, you're supposed to find angle CDB. Now CDB is right over here. Okay, so at this point in time, I think what we can do is we notice that CDB, the angle, is actually formed starting from these 2 points. Okay, where you extend the line from C to D and B to D, right? So my question will be, if we want to use angle in the same segment from the same 2 points C and B, can I extend it elsewhere to get another angle in the same segment? That means this portion here, the major segment. Okay, answer is yes, right? You notice from the same 2 points, okay, I can extend to A, from B to A. So this angle is 44 degrees, right? So if this angle here is 44 degrees, using the same 2 points C and B, I extend to the other point D. These two angles has to be in the same segment. Therefore, they are equal, 44 degrees. Okay? Therefore, in part 1, angle CDB is equals to 44 degrees. I just write angles in same segment. Okay? Done. Alright? Can I introduce you now to another property? So what we did just now was, when we take a look at the diagram, okay, they are in the same segment. So let me just draw quickly. Okay, so let me just shade the region. Okay, we have the major segment over here, and then we have the minor segment over here. Okay, so just now we actually using point A and B, we extend, okay, to get an angle in the same segment. So I have an angle there in the yellow region. Okay, now what if instead of having both angles in the yellow region, using the same 2 points A and B, I extend in the other region? Okay, so these two angles, they are no longer in the same segment. They are angles in opposite segment. Okay, so what is their relationship in this region? Okay, so using the same example just now, let me just move the angle to 70 degrees. Now this is angle in the same segment, right? So I'll just show you just now, same segment. You notice that all the angle will be the same, 70 degrees. Now I'm going to make it bigger, 85 degrees. Okay, same segment, they are the same, right? So I move it back to 70. Okay, now I'm going to move B such that it goes in the opposite segment. Okay, so what do you notice about the angle now? Angle here is 110, whereas the one above is 70. Okay, let's try to find the relationship. Okay, let me shift it here. Now I'm going to change the angle to the one above being 80. Now the one below becomes 100. So what you will notice here, the angle in the opposite segment, they add up to 180 degrees. Okay, alright, so that brings us to the second property for today. Angles in the opposite segment add up to 180 degrees. Alright, let's look at the example just now. So we have solved part 1. If I were to